So, thank you for joining us today as we are close to the launch of the historic Sirius 2 mission, which aims to make Sirius Web open source. Sirius Web is a framework from OBO for building cloud graphical modeler for a specific domain for a DSL. I'm Melanie Batz at OBO's Office of Communications. We moved this press conference at your home, originally planned as usual at Ludwigsburg, due to cold weather in Germany. Today, we'll hear lots about the launch by our great guest, as we have Stéphane Bégodeau, software architect for the Sirius Web project. Hi, Stéphane.
Hi, Melanie. Well, first, I've got to tell you, I'm starting to get butterflies because I can tell you here on the ground, I don't see any clouds in sight over Launchpad 42. So we are crossing our fingers and toes that this launch takes off. It kind of feels like it's going to.
Thanks, Stéphane. OBO spacecraft will launch the Sirius 2 mission from Code Launch Complex 42 at Nantes Force Station in France. Since its beginning, OBO believes in open source. Just a quick reminder, Sirius 1 mission previously launched Sirius to the Eclipse Foundation with OBO's and Thales astronauts on board back in 2013. The first mission was a success with the adoption by a large community of Sirius Desktop. Sirius Desktop is a framework based on the Eclipse platform to create graphical modeler dedicated to a specific domain. Sirius 2 mission, 7 years later, aims to release Sirius Web to the cloud. Sirius Web is a cloud-based evolution of Sirius, 100% open source. We think at OBO that this contribution will be a key factor leading to the creation of hundreds of graphical modelers. We expect something like what we currently demonstrated with the Sirius Gallery today, but no, this will be easily accessible through the web. So we decided to contribute Sirius Web in the Sirius project because it fits well in the scope of the actual Sirius project. Our purpose is to help the very active Sirius community to push graphical modelers to the web. We do not aim to provide just some small technological bricks, but want to provide an easy-to-use solution to make cloud graphical modelers. For OBO, the decision to open source Sirius Web strengthens our product-based business model while being faithful to our open core approach. This mission is also in charge of the launch of the OBO Cloud Platform, the solution offered by OBO for deploying enterprise modeling tools to the web. So as you can see, we are almost 3 minutes before the launch. So I will take this time to explain quickly the basic principles of Sirius. Our purpose is to bring the spirit of Sirius to a new technological space. With Sirius, first, you define your domain by defining a meta model thanks to EMF. Then you provide a Sirius configuration to specify the mapping between the different concepts of your DSL and how this should be represented graphically. As a result, you get a graphical modeler dedicated to your DSL, a workbench for your end users. With Sirius Web, we keep these principles of Sirius. You still have your meta model as an e-core. You still define a Sirius configuration. The idea now is to not provide an RCP application, but a web application. Your end users, instead of opening Eclipse, will open the browser to access your modeling workbench. To sum up, with Sirius Web, modeling tools developed with Sirius can be installed on a web server and are rendered in a browser. Stéphane, could you provide us an update on the current launch, please?
Okay, so let me tell you what's happening with this rocket. We are loading thousands of lines of code right now. The crew access arm has been retracted. The launch escape system has been armed. EMF JSON, Sirius component, and Sirius Web are strapped into the capsule. We are 5 seconds before the liftoff and the countdown is running.
3,
2, 1,
0, ignition and liftoff. OBO has launched. This is a new era for the Sirius project. The Sirius Web source code is now available on GitHub, on the GitHub of the Eclipse Foundation. So what do we open source, Stéphane?
Well, we have open source 3 different repositories. First of all, EMF JSON, an open source component to load and save EMF model as JSON resources. Sirius component with backend and front-end components that are reusable to create your own web application. And Sirius Web, a sample web application which uses the component available in the whole Sirius project to create a graphical designer for your DSL. So on the back end, Sirius Web relies on Java, Spring, Reactor, and EMF.json, for example. On the front end, we are using technologies such as React. And between the two, we are communicating using HTTP and WebSocket connection, thanks to a GraphQL API. So let me show you how you can get started to create your own Sirius Web application for your own modeler. So first of all, you can go on github.com/eclipse-sirius in order to see what we have open source today. So you have the repository for EMF.json of Sirius Component and Sirius Web. Let's have a look at Sirius Components. So inside of this repository, you will have the backend and frontend folder with tons of code inside of it. So first, let's have a look at the backend. As you can see, it contains countless of projects, for example, to create forms or diagrams. If we have a look at the diagram, you will see everything to create your diagram with edges, label, nodes, the various styles, and how to render this diagram to give it to the front end. If you want to have a look at the code of the front end, you will see here the whole code of the user interface of Sirius Web. And finally, in the Sirius Web repository, you will have the code sample to get started to build your own application. So for that, you will have the backend and frontend folders with two small projects to build your application on the backend, and one very simple React-based project for the front end. So I've cloned all this on my computer and imported the front end on Visual Studio Code, so you can see what you need to get started. So here we have two quite small JavaScript files that are easy to understand. The main code is right here in the main.tsx file. As you could see here, we are importing the various pages necessary from Sirius Component, and we are just connecting those pages with the path that we want them to use. So you don't need to modify anything to get started here. As for the backend, I've imported it in Eclipse. So here we have two projects, the Sirius Web frontend one that you don't really need to modify, and the Sirius Web sample application in which we will do most of the changes. So first of all, here, if you want to create your own version of Sirius Web, you will need to have your own meta model. So here I'm taking Flow, an existing meta model that I have. So you could see this flow.ecore file with the various concepts of my domain, such as system or fan, which have attributes such as the temperature, the weight, and so on. We have also the generated code here, just like in any regular EMF project. And I also need to have the description of the diagram that I want to use in a Sirius project with my ODesign file. So in this ODesign file, I will describe the topography diagram, and I will detail how each concept is displayed. For example, my system will be represented by a node with a light gray background. My fan will be displayed using an HVG image, if I zoom on it, as you could see here, and so on and so forth. So here I have the description of my diagram, and in the flow.ecore, the description of my concept. Now you need to tell Sirius Web how to find those concepts. So for that, you'll need to modify two files, the sample EMF configuration and sample Sirius configuration. And you will need to have a dependency in the pom.xml to your project. So you could see here that I'm depending on those other projects. So in the sample EMF configuration, I just need to have a reference to my meta model. So here, flow package, that's one of the Java class generated by EMF. And you can also add a dependency to the adapter factory in order to tell us how to interact with your code. And in the sample Sirius configuration, you just need one thing. You need to give us the path of that ODesign file. Once you've done that, you are ready to go. You can start launching your Sirius Web server. In order to launch it properly, you would first need to start your database. So you can go in the scripts file of the Sirius Web project, and you would have a small script to initialize a Postgres Docker container to get started. So let's run the server and have a look at the result. So here, the server is starting, initializing the database, and everything is good. So if I open Sirius Web, you can see that I don't have any project right now. So let's start by creating one. So here, let's create a demo project. Inside, I will create a first model. You could see all the concepts I told you about. So the system, the processor with the fan, and so on. I can navigate in my concept on the left, and on the right, I can see the properties of the currently selected element. I can create the topography diagram thanks to the definition which was in the ODesign. And now you can see that I have my system with its light gray background. I have my fan and so on. I can edit my diagram using the Explorer to create, for example, new objects or additional diagrams if I want to. I can also edit my diagram directly inside of the editor. So for example, let's create an additional device. This device will have a processor, which will be a CPU. Let's create another one. I can edit the name directly. I can also create relations between my elements. I can edit the properties of the elements on the right. So for example, let's change its color. Let's change its size. You can also see that the layout is automatically computed so that your diagrams looks nice at all time. And you can this way edit very easily your EMF models in your web browser. So here I have my device. I could change its temperature. For example, let's put 80 degrees. But if I put 80 degrees, you can see that I have this red border, which is not very visible. So I can try to have something a bit more flashy. So for that, let's put 0 for the temperature. And let's go back to my server. I'll shut down my server and I go back to my ODesign file. So here, you can see that my system is in light gray, but if the temperature is above 40 degrees, I will have an additional appearance, which is with a light gray background, but this time, you can see here, with the border color red. I want something a bit more visible, so let's make the background red too. So I can edit this property, save my ODesign file, and if I want to deploy it once again, I would need to build this project using Maven, publish it on the Maven repository, and refresh the other project. So I'll make something a bit quicker. I'll just paste it in this EclipseCon folder, and I'll modify the path in the sample series configuration to say EclipseCon. So now it will take this new version. If I restart my server, and if everything goes well, now you will see the new style for system with a temperature above 40 degrees. Okay, so my server is now running again. I can refresh here. If I change the temperature for 80 degrees, you can see that the system is on bright red. So I can quickly edit the definition of my diagram, refresh it in the web browser, and see the impact of my changes.
Okay, thanks, Stefan, for this great demo. To give some more context, I would remind you that currently we contribute Sirius as an open source project, and we provide also the OBO Designer Community Edition. With that, you have all you need to work with Sirius Desktop and create desktop graphical modeling workbench relying on the Eclipse platform. We also provide the OBO Designer team for organizations needing real-time collaborative edition in Eclipse-based workbenches. The main issue faced by our customers arises when they need to distribute the bundle to their own users. A truly effective deployment is complex and difficult to achieve. Many struggle to either deploy or maintain their solution, and their team are feeling the pinch. To solve these challenges, we decided to develop Sirius Web. So, Sirius Web, modeling tools developed with Sirius Desktop can be installed on a web server and are rendered in a browser, as Stefan just demonstrates. And finally, we provide in parallel the OBO Cloud platform for enterprise usage. The OBO Cloud platform provides a set of cloud-based technologies for building and deploying modern and online modeling solutions accessible from web browsers. Within OCP, you can create graphical modeling solutions that can be used collaboratively from a web browser. It provides features dedicated to an enterprise usage, for example, the capability for private public projects to provide an integration with other web applications, or also the possibility to visualize collaborative edition on shared models. Stefan, maybe could you demonstrate some of these enterprise capabilities offered by OCP?
Yeah, sure. So let's go back to my web browser. So here you have seen Sirius Web, that's the pink and purple one. And here we are now in OBO Cloud Platform, the green-blue one. So on top of all the features that you have seen in Sirius Web, OBO Cloud Platform provides a layer of security with, of course, authentication. So here, let's log as the admin. Once I'm logged inside of OBO Cloud Platform, I have access to the same features as in Sirius Web, so I can create a project. But this time, my project can be private, only accessible to me, and I can decide how and when I will share it with other users. So for now, let's create this private project with a model and a topography diagram, just like before. But let's try to connect with an additional user to see how things are working this time. So if I open a new web browser and connect on the same server, this time I will be connected at John Doe. And as you can see, I don't have access to the private project, which is located here, but I can go in the settings, and in the settings as the admin, I can make my project public. So now John Doe will be able to see it, but once he is inside, he only has access to the project with in a read-only mode. He can't create new models or he can't create new representations. So for that, I can go to the team management tab and add John Doe to the contributor team. So now he will be able to create new elements and edit my models. So if both users go back to the project, as it's the case right now, we have added additional information to let you collaborate in real time with your colleagues. So let's, for example, start by opening this topography diagram. So now as the admin, I've opened it. And if John Doe tries to open it at the same time, you can see that we have an indicator on the top right, which lists all the users who are currently watching the same diagram. This way, you know that you will be able to interact with your colleague and see their changes in real time. On top of that, you can also, for example, see the properties of your element collaboratively. So here, John Doe is aware that the admin is connected and viewing the same elements. So as you can see here, we have John Doe visible because we are seeing the same diagram, and John Doe visible because we are seeing the properties of the same object. But now if I try to edit one of the properties of this object, a small decorator will be visible. So I'll zoom a little. So here, as John Doe, I know that the admin is currently editing this name field. And if the admin is using tabulation to change the currently focused field, you can see that I can follow where he is working. So of course, you can have, just like in Google Doc or any other collaborative tool, changes in real time. So I can change the name changes on the other side. I could, for example, change the size of an element. You can see that the diagram is modified in real time on both sides. And I can do this, of course, on the other side without any issue. Can change the temperature, can change the name, can change pretty much anything. And this way you can work with multiple users at the same time on your representations.
Thanks, Stefan. That was great. If you want to try Sirius Web, so you can go to GitHub and just clone the repositories and start the server locally on your computer. But if you want also to try Sirius Web capabilities without having to start from the source code, we deployed a public beta instance for you. You just have to sign up and we will invite you to join to try OCP and Sirius Web. So,
to conclude, remember that Sirius Web provides a set of cloud-based technologies, 100% open source, to specify, thanks to the configuration file, a modular dedicated to your domain and make it available in a web browser. It comes with all the CRUD capabilities and diagram rendering with assisted layouts that we've shown.
On another end, you have the capability to use the OBO Cloud platform. It is built as an open core product relying on Sirius Web. It will help your company to deploy professional online modeling solutions. And we will offer through OBO Cloud platform a Sirius Web build extended with enterprise-grade features to deploy on public, private clouds or on-premise, and including support and upgrade guarantees. Thanks for your attention. And if you have any questions, we are here with Stefan to answer them. And also we will have also a virtual booth, so do not hesitate to join us later to discuss about Sirius Web, as I will be there within the next days. So we can start because we already have some questions. First one, will specification editor web or desktop based? Today, we are using the same editor as the one you are used to with Sirius Desktop. So it's exactly the same. We're just reusing the ODesign configuration and interpret it for the web solution. Second question, is web editor code generated based on a specification or web editor interprets specifications in runtime? Maybe Stefan, can you answer this one?
Everything is interpreted during the runtime. No code generation involved.
Yes. Third question, is it generic enough to convert any EMF GMF modeling tool to show UI diagrams on the web? This is not our purpose. Our purpose is to make possible from people using Sirius Desktop to make this configuration on the web. So if you only have an EMF GMF modeling tool, we are not using that because we are reusing the definition we did with Sirius. So as if you are using EMF and GMF, you have no specification, it's not possible. Another question, can a Sirius configuration be created textually or only with this tree-like editor? Stefan, one is for you.
Right now, it can only be created with the tree-like editor, but you could create the configuration programmatically if you really want to. So you could use pretty much anything you want and then create it programmatically quite easily, but it may be a bit verbose to do so.
Next question, how does Sirius Web relate to eCore tools in the cloud? Is eCore tools in the cloud using Sirius Web or are they two projects independent? So I just discovered EcoTools in the web yesterday. So there are 2 different projects and 2 independent projects. But you should know that we aim with Sirius Web to make the meta-modelization phase also in the web in the next months. So it's on our plan to get something not exactly like EcoTools, but something that would help you to define your meta model, and then also your configuration, your mapping, your graphical mapping in the web directly. Does Node support long auto-wrap multi-line labels? This one is for you, Stefan.
I'm not sure. I haven't tried it, but there are solutions to make it work. So we would need to explore it first. I can't give you a definitive answer right now.
Okay. Would it make sense to aim for the Sirius Web-based configuration editor to be implemented as a Sirius editor? Dogfooding, basically, it's exactly what I said. Our purpose is to make this part also in the web next year. So this is in our roadmap, definitely. What size of diagrams, nodes, ages is currently sensible, editable with Sirius Web? This one is a great one. Our purpose today is to support what our customers need. So we are around, if I well remember, I think that with 350,000 semantic elements, we are still okay to edit. And maybe, Stefan, do you remember a little bit more about the size of the diagrams you tried?
The size
Only nodes available on the diagram, it was around, I don't remember, it was thousands, but I'm not sure.
Something like that.
So next question, are you planning to support additional metamodel technologies in Sirius Web? We are free. The architecture, in fact, is not related to EMF. As you saw, we are using today EMF models because the Sirius community is used to work with eCore, but the architecture is not linked to that. Maybe, Stefan, you can explain, because you are the architect of the...
Yes, sure. So we are providing in Sirius Component support for EMF as the data structure and for ODesign files as the way to define your diagrams, but you could not use those 2 components and provide your diagram definition using our Java APIs, but you could also provide your data structure using our regular Java API or to connect it with other metamodel technologies. So Sirius Web is using EMF as the default option, but we are not tightly coupled to EMF.
Okay, thanks, Stefan. I think that our time is over, so thanks everyone for joining us. And as I said, if you have some more questions, do not hesitate to contact me on the booth or directly. I will be happy to answer all your questions. See you, bye-bye.
Thank you.
Thanks.